The North Atlantic is one of the most rapidly changing ocean regions as a result of climate change. What that means for North Atlantic right whales is that how much food they have available is changing. Maybe even more importantly, the location and distribution of that prey is changing really rapidly. They're now moving into areas where people don't expect to see them. They're much more vulnerable to those direct impacts like entanglements, like ship strikes, vessel traffic, lots of fishing activity, noise, climate change are probably contributing to the reduced birth rates. The New England Aquarium has been collecting photo identification data on individual whales since the 1980s. We essentially know for almost every female whale in the population how often she's given birth, when she's given birth, how many calves she's produced. We can start to ask really interesting questions about what's driving reproduction, how often are they reproducing. So we paired that reproductive data set with an aerial photogrammetry data set, which is essentially a fancy way of saying that we flew over the whales and we took pictures of them. We have photos of individual whales that we can use to measure how long whales are, how healthy they are, how fat they are. A fat whale is a happy, healthy whale. A skinny whale is not doing so well. We can combine these two data sets to look at how things like size and body condition are influencing reproduction in this population. The first thing we were interested in is what has happened to growth rates of these whales over time. What we found was really striking. A North Atlantic right whale born today is expected to reach a maximum length about 1 meter shorter than a whale born 30 or 40 years ago. What does that mean? Is it a big deal that these huge whales are a little bit shorter than they used to be? What we found is that smaller females produce fewer calves over their reproductive years. The bigger you are, the more calves you can produce. If you're a short whale, you've got fewer sort of total energetic reserves. Where you store all your energy is in your blubber, you're just packing on less blubber overall because you're shorter. We see that manifesting in longer recovery periods between pregnancies. If you think about the reproductive cycle of a whale, the first thing you need to do is pack on a lot of weight prior to giving birth. Then you get pregnant, you give birth, and you use a lot of those reserves to nurse your calf, make sure that it grows big and strong. You have to build those reserves back up before you can reproduce, give birth, and nurse another calf. For these smaller whales, that recovery time is quite a bit longer than for much larger whales. That sort of adds up over their lifespan of 30, 40, 50 years. A shorter whale is going to give birth to many fewer calves than a larger whale. Mom's condition and size also influence the calf's condition and size. So these shorter and skinnier whales are also probably giving birth to shorter and skinnier calves. And when you only have a few hundred of these whales left, every individual becomes very important. If they're all stunted and smaller and have reduced birth rates because of that, it becomes a big deal. If you're entangled in fishing gear, you're going to be stunted in your growth rates and you're going to end up shorter than a whale that isn't entangled. In order to make the population more resilient, it would be very helpful if we could reduce or eliminate some of these impacts like entanglements and ship strikes. It's definitely difficult. It's not easy to, prevent these impacts or reverse a major decline of a population like this, but I hope that this actually gives sort of actionable targets to help recover the species.